welcome to your weekly introduction videos. This week we're going to work on being able to find the volume of a prism, okay? And obviously we'll discover exactly what a prism is as we go through. Last week we looked at finding the volumes and surface area of a cuboid. So this week we're going to extend it out and do some more complex volume, and then next week we're going to look at the surface area of a prism, something that's slightly more complex. Okay, but before we actually do that, I just want to make sure that you actually remember some basic concepts about area and perimeter. So I'd like you to have a go at these questions here. Let me just give you a few hints to get you started. If you want to find first of all, I'd like you to find the area of this shape, and if you can, find the perimeter as well as a little extension, okay? And then I would like you to find the area and perimeter of these three shapes down here, these sort of circular looking ones. The first one, the basic structure of how you're going to do it is you're going to split it into two shapes, okay? And so find the area of those two shapes and add them together. The second one, well, you're trying to find the area, then you're basically looking at these as fractions of a circle. So a little hint here, remember the area of a circle is equal to pi r squared. So pi times r squared. R is the radius of the circle, okay? So you need to be able to use that formula. For perimeter, you need to be able to think about the circumference of the circle, so the distance around the outside of a circle, which is 2 pi r. 2 times pi times the radius. So you're going to need those formulas in order to do it. So stop your video and have a try, okay? Right, okay, so to find the area of the first shape, what we're going to do is we're going to split it into two shapes. As I said, we've got a rectangle and a triangle. So the area of the rectangle, well, what's the formula for area of a rectangle? It's base times height. Remember last year, and I did this with you, so many of you, I said, how do you calculate area? And you said, oh, times them. What does that mean? That means absolutely nothing, okay? Remember, I said you should always say to me, if I say, how do you find area? You mean, how do I find the area of what type of shape? Because each type of shape is different, okay? And a rectangle, you're going to use base times height. That's your formula. So you just say times it or divide it. I hate that response. What are you timesing? What are you dividing? Anyway, so area of a rectangle is base times height. So 6 times 8 equals 48. So that's the area of the rectangle. Then we've also got the area of shape 2, which is a triangle. And remember that the area of a triangle has formula base times height, and then divide that answer by 2. So the base of the triangle will be 6, because it's the same as the base of the rectangle, times the perpendicular height, which is 5, and then divide by 2, which is 15 centimeters squared. So the total area is going to be equal to those two areas added together, so 63 centimeters squared. Make sure you're using the right unit of measurement. Now, based on last week's work, if I asked you to find out what that area is in millimeters squared, you'd be able to tell me, okay? But it doesn't, so we'll ignore that. What about the perimeter? Well, the perimeter is tricky here, actually. Remember what perimeter is. Perimeter is the distance around the entire length of the shape. So I need to add up all these green lengths, go all the way around the shape. So it starts off nice and easy because it's going to be 8 plus 6. Sorry, my alarm's going off there. Stop that. 8 plus 6 plus 8. Okay? But what we don't know at the moment is the length of the sides of the triangle. So these two sides here, I don't know what they are. Well, actually, I taught you a little technique earlier this year to be able to help you find out what those lengths are. Okay. Now let's just draw that triangle a little bit bigger. What I can do is I can split it in two down the middle. And I know that this distance is 5, the height is 5, and I know that half of the base is going to be 3. So now I've got a right-angled triangle where I know two sides. What I need to do is find the other side. Well, remember, Pythagoras' theorem can help me with that. So let's just call that length x for the moment. So remember, it means x squared equals 5 squared plus 3 squared. So do that on a calculator or in your head. 25 plus 9 is 34. So x squared equals 34. So x is the square root of 34. Okay, so root 34 is equal to 5.83 to three significant figures. Okay, and this must be an isosceles triangle. So this is 5.83 and this is 5.83. So I'm just going to add them on 5.83 plus 5.83. And that is going to be equal to the perimeter. All the lengths around the outside of the shape added together. 8 plus 6 plus 8 plus 5.83 times 2 gives me 33.7 centimetres to three significant figures. Round off your answer to three significant figures. Okay? Right, so that deals with question 1. Now, what about the areas? We'll do areas first of these circular looking things, okay? Now, what you always have to do with these is consider them to be a fraction of a circle. So if it was a full circle, then the area of the full circle would be pi times 2 squared, pi r squared. But it's 3/4 of a circle. So what I'm going to have to do is times that by 3/4. And I can just throw that directly into a calculator. So pi times 2 squared times 3/4, because it's only 3/4 of a circle. And that gives me two three significant figures, 9.42 centimetres squared. Okay, so that's the first one. The second one, which is a semicircle, well, that's easy. Remember, it's half a circle. So it's pi times 6 squared. Why is it 6 and not 12? Because remember, the formula for area of a circle is pi times the radius squared, and 12 is the diameter. So it's pi times 6 squared, and then because it's only half a circle, we're going to divide it by 2. So let's put that in my calculator. Pi times 6 squared divided by 2 equals 56.5 centimetres squared to three significant figures. Okay? And the last one. Hopefully you're getting the idea now. This one is 1/4 of a circle. So pi times the radius of what would be the whole circle. And it's 1/4 of a circle, so just divide it by 4. Okay, put that into your calculator. Pi times 5.5 squared. Divide your answer by 4. And I get 23.8 centimetres squared to three significant figures. Okay? Now, perimeter, everybody gets these wrong. I don't know why you guys find this so hard, but even some of the very best students I teach get this wrong. Okay? Now, remember, perimeter means all the way around the shape, not just a bit of the way around, all the way around the shape. So it's the length of this, what we call an arc, but don't forget these two sides here. Okay? So what would the circumference of the whole circle be? The circumference of the whole circle will be 2 times pi times r, which is 2 in this example. Okay, circumference of a circle is 2 times pi times r. But the arc will only be 3/4 of that length. Okay, so that now tells me That expression that I've got written there tells me this distance here. That's not the perimeter though. For the perimeter, I have to add these two here as well. So I'm going to add 2, and then I'm going to add another 2. Really should, I suppose I should call that perimeter, not circumference. Okay. I hope that makes sense. Everybody gets it wrong. I really don't know why. You just forget, I suppose. So 2 times pi times 2 times 3 over 4, which is the arc, plus 2 is 13.4 centimetres to 3 significant figures. Okay. What about the second one? Well, that's going to be 2 times pi times 6 to give me the arc. That will give me the, 2 times pi times 6 and then divide it by 2 because we're only going halfway. That will give me the arc. Don't forget to add on the diameter. I've got to add this on. This is also part of the perimeter. Okay, so now use a calculator. 2 times pi, oh, go away. 2 times pi times 6 divided by 2 plus 12 equals 30.8 centimetres to 3 significant figures. Okay, last one. The perimeter is going to be equal to 2 times pi times 5.5 over 4, because it's a quarter circle, will tell me just that piece there. Then I'm going to add on this and this, so it's 2 radii. So plus 5.5 plus 5.5, and just put that in your calculator. So 2 times pi times 5.5 divided by 4 plus 2 lots of 5.5 equals 19.6 centimetres to 3 significant figures. Okay, so please don't forget these bits. Everybody forgets about them. Don't be the person that forgets. Okay? Right, I'm going to stop the video there and then